So, we are now continuing with the same problem, and that time I was considering capital X k given. So, you multiply by e to the power minus j 2 pi k by n into r times that. Originally I took 2 pi k by n, now r times that. R actually can be 0, 1, but the same range, okay, to make life simple. Then what is x 1 n? So, I carry out that inverse DFT of this capital X 1 k. So, this I put back here, and I get this, capital X k e to the power minus j 2 pi k r by n, that is coming from the second term, j 2 pi k by n into minus r. First term comes from that inverse DFT formula, and this is what. So, now I start with x 1 r. R means n equal to r, that means this is 0. So, it is this inverse DFT of x n at n equal to 0, if it is 0. If it is 0 and capital X k is the inverse DFT of x n sequence with this index being 0, right. So, you should go back x 0. Okay, you remember what is x n? That was x k e to the power j 2 pi k n by n summation over this. So, x 1 r means small n is r here, r minus r 0. So, this summation is what? 1 by n present, 1 by n, summation k to 0 to n minus 1, 0 to n minus 1, capital X k, capital S k. Okay. E to the power j 2 pi k by n, same here, all right. But this summation here, this index is becoming 0, that is as though 2 pi k into 0 by n. If this is 0, it is x 0, because for x 1 it is r, x 1 r, that means n is r here, but r minus r is 0. So, e to the power j 2 pi k into 0 by n. If we have e to the power j 2 pi k into 0 by n, this 0 means x 0. That is why x 1 r equal to x 0. In the same way, if you put x 1 r plus 1, that means this n is r plus 1. So, r plus 1 minus r is 1. So, as to this summation with index n is 1, that means x 1 dot dot dot. I go up to capital N minus 1. So, capital N minus 1 means n minus 1 minus r. Okay, as though this index is small n index is capital N minus 1 minus r. So, it is x n minus 1 minus r, and then I go to x 1 0, but x 1 0 from the property of DFT you have seen that if you take the inverse DFT and suppose this is a sequence, if you go beyond this, it becomes periodic. So, if you are going to nth point, whatever you observe, that will be same as this 0, 0 plus n. This block will be repeating, right, periodic. So, if I take the inverse DFT, but allow the index n to go beyond this capital N minus 1, say to capital N. So, that value x 1 at capital N will be same as x 1 at 0, because of the periodicity. So, x 1 0 is same as x 1 capital N, but x 1 capital N in this formula, if you put capital N minus r, as though here this index n is capital N minus r. So, it will be x n minus r. So, 0 1 n minus 1 minus r, then n minus r, then x 1 1 will be, if it is 1, this value will be same as whatever you had at n plus 1, because of periodicity. So, x 1 capital N plus 1, that is capital N plus 1. So, as though index is n plus capital N plus 1 minus r. Dot 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 dot, finally r minus 1, that is same as again, because of periodicity you add capital N to that, you will get the same thing, r minus 1 or r minus 1 plus n, because of the periodicity you will get the same thing. But if you put r minus 1 plus n, r cancels, you are left with capital N minus 1, as though this is capital N minus 1, this is this. So, graphically what it means? that this was the x n sequence, this is a x 1 n sequence. Here I had x 0, it will go to x 1 at rth point. So, it will go to rth point. Then I had x 1, sorry x 1, it will go to r plus 1th point, dot 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 x 1 n minus 1, who will come n minus 1 minus r. So, somewhere here is x n minus 1 minus r, that will go to n minus 1. So, you see this is getting shifted by r, this is getting shifted by r, this is getting shifted by r, because n minus 1 minus r plus r is n minus 1. So, they are getting shifted by r, but the next guy, if the next guy is this, okay, that is at x, next is n minus r, right. It is increasing by 1, 0, 1, 2, 3. So, after this is n minus 1 minus r. So, next will be n minus r. N minus r goes to x 1 0. So, x 1 0, that is, it does not go to the right. You can say it goes to the right, you can say it goes to the right, but I am, because of periodicity, whatever you have within this block, same will repeat. So, this will be same as this. Since I am interested in only one block, so basically this will come here. So, you can say this is coming back here. Okay. Then the next guy, if the next guy is this much, this will come back to the next, dot dot dot, and finally at n minus 1, if it is x n minus 1, this comes at x 1 r minus 1. So, here okay. So, x 0 shifted by r, x 1 shifted by r to the right, dot dot dot, this shifted to the r and it goes to the last point capital N minus 1. Next guy will be shifted back to the 0th point, next will be the first point, next will be the second point, dot dot dot, last guy will come to r minus 1th, because x 0 came to rth. So, I can go only up to the guy before this r minus 1th. This is called circular shift, it is a right circular shift by how many index at a time? R. Everybody is getting shifted r times, they are getting shifted in the forward direction, and from this point onwards it is shifted circularly. Okay. This is a very important property. Another thing relates to convolution, and that is another very important thing. Earlier we had seen that suppose I give you a sequence x n from 0 to n equal to 0 to say n minus 1. Okay. X n has DTFT and another sequence h n Okay. Now, there we saw that if we multiply in frequency domain, that is this, then inverse DTFT of this is the convolution of this. There is convolution in time domain, gives a sequence whose DTFT is the product of these two DTFTs in frequency domain. Now, suppose x n, it has got DFT, that is the DTFT sampled capital N number of times n point, we say n point DFT, and okay, in both cases k equal to 0, 1 dot 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 n minus 1, where this n is same as this n, the length of the sequence. Okay. So, here also I multiplied the two DTFTs. Here instead of the DTFT as such, I am taking kth sample of this as xk, kth sample of this as hk, multiplying them xk, hk. And then I take the inverse DTFT of this, inverse to get yn. That time when you took inverse DTFT of this, I got convolution between the two. Now, if I take inverse DFT of this, okay, you can call this product as capital Yk. So, I have got capital Y0, capital Y1 up to capital Yn minus 1, because k takes those values. So, on that sequence, if you carry out IDFT, you get again a length n sequence, say Yn. What will be Yn in terms of x and hn? Will it be linear convolution? It will be no. Okay, because linear convolution as such, if you convolve the two sequences, its length increases. But here, when you take IDFT, Yn also is length n. So, obviously, it cannot be a convolution between xn and hn. Then what is Yn? So, that we can work out, and that is a very important thing. To work that out, we carry out this. We know that xk is instead of m, I give another symbol here, m. Okay. Now, IDFT, that means Yn is 1 by capital N, IDFT means summation over k, Yk, that is this product, e to the power j okay. Since small n is used here, let me change this index also from here. Okay, let me call it L, because n is used up here. So, I cannot use another n there, all right. Now, capital Xk replaced by this, Hk replaced by this. So, what I have then the summation this is your capital Xk, then again capital Hk. N minus 1, sorry. So, capital Sk, capital Hk into e to the power j right. Now, there is triple summation. So, I can interchange the two summation. I will bring the outermost summation, I will make it the innermost summation. In that case, you will have 1 by n outside, so L equal to 0 to n minus 1, then m equal to 0 to n minus 1, and inside is over k. So, all functions of k should be here. X L will be here, will come as common only in the context of summation over L, because it depends on L. X m, sorry, one is this is not x, sorry, this is h. I made this mistake. Capital X k came from x, capital H k should come from h. So, it is not small h, because there are two sequences, so it is not x. I am very sorry. Okay, it is h. So, this is h, all right. So, this x l came here, h m, because it depends on m, this comes in this. But this exponential, this exponential, this exponential, they all are function of k. So, they go inside. So, you have got e to the power j 2 pi k by n into small n minus m minus L. All right. Now, if it is 0 or if it is capital N or if it is 2n, 3n minus capital N minus, what we will have e to the power, for instance, suppose it is 0, e to the power 0, 1, 1 plus 1 plus 1, you will get capital N, that capital N and this 1 by n will cancel. If this is not 0, suppose this is capital N, again n will cancel, so e to the power j 2 pi k is 1, 1, 1, 1, 1 you sum, you get capital N, capital N, capital N cancels. Same if it is 2 capital N, 3 capital N, 4 capital N. If it is 2 capital N cancels, e to the power j 4 pi k, which is again 1. So, you sum over capital N, 1 by n cancels. If this is minus capital N, even then is no problem. Minus capital N means minus capital N and n. So, n cancels, so it becomes e to the power minus j 2 pi k, which is again 1. So, same thing. So, when the summation, if n minus m minus L is some r to the power n, r can be 0, plus minus 1, plus minus 2, dot dot dot. That is, if it is 0, n minus m minus L is 0. If it is 1, it is capital N. If it is minus 1, minus capital N, and so on and so forth. In that case, what happens? This will give you to capital N and capital N cancels, you have to carry out this summation. Okay. That will do, but if it is not, that will come to, but suppose it is not. If, first let me do this case and then I will come to this. Suppose it is not equal to this. In that case, it will be just an integer. Okay, it will be an integer, and then this GP series, if you sum, this will turn out to be 0. If you call this integer to be, suppose you can give a name, n has been used, m has been used, L has been used, r has been used, right. So, what is still there? Suppose you call it p. Okay. N is integer, m is integer, L is integer. So, n minus m, L you are choosing from here, m you are choosing from here. So, n minus m minus L, and n is fixed from outside. You want to find out y n at a particular n within the range 0 to capital N minus 1. So, integer minus integer minus integer is an integer, can be positive or negative, does not matter. And it is a summation e to the power j 2 pi k by capital N into p. So, if you take e to the power j 2 pi into p by n, then whole to the power k. If you call it a, so e to the power k from 0 to capital N minus 1. So, summation of this will be 1 minus a to the power n by 1 minus a. So, a to the power n means if you have 1 minus this to the power n, n will cancel, so to the power j 2 pi into integer p minus 2 pi p by n. All right. Now, look at this m n minus m minus L. Okay. The numerator part is 0 because this is 1, 1 minus 1 is 0. Denominator we have seen earlier and we can explain again, denominator cannot be 0. Why it cannot be 0? Because it cannot be 0 because for it to be 0, this must be equal to 1. So, in that case p must be either 0 or capital N or 2n and like that. Okay. But that case we are not considering here. For this to be denominator to be 0, p must be either equal to 0, this is your p. P must be either equal to 0 or n, 2n or minus n, minus 2n, dot 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 dot, that is of this form. But I am assuming this case first, that is this is not equal to of this form. which means denominator is this is never equal to 1 and therefore, this is never equal to 0, but numerator is 0. So, this will be 0. So, in these cases there is as L is moving and M is moving, if this summation is not equal to either 0 or capital N or 2n, then this is goes. So, I have to only consider these cases, and in these cases this summation will give rise to capital N and 1 by n will cancel. So, we will be left with this. That means y n is given by this part with this condition r into n, either r equal to either it is 0 or n or 2n or minus n minus 2n. Okay. So, in this summation you choose L and M accordingly, but for a given small n, but only that L that M. So, that n minus M minus L is either 0 or capital N or 2n or minus n, only those choices of L and M from these two summations will be allowed. Then only, because that is the this is the condition. If it is not so, summation was 0, we have found out. So, if it is not so, that case is gone. So, we are considering only this case where n minus M minus L is r into n. There is either 0 or 2n or minus n minus 2n like that. And in that case, if this is there is 0, n, 2n, minus n, minus 2n, whatever, this summation is capital N, n cancels. So, you are left with this summation. But constraint is M and L should be chosen from this range. So, that n minus M minus L is of this form, either 0 or n, 2n, 3n or minus n, minus 2n, minus 3n like that. Then whatever you get, that will be your y n. So, let us try to see what are the choices of L and M we can pick up under this constraint, okay, and what will be the summation then. Okay. So, suppose I have got one axis n, sorry M. The small n is your choice. You are trying to find out y at a small n, but small n is within this range. Isn't it? You multiply the two DFTs and taking the n point I DFT. Okay, that is how you got. You remember these two DFTs you multiplied, called it yk. You take n point I DFT. So, this is a length n sequence, length capital N sequence. So, I am finding out y small n for small n within this range. Okay. So, small n is your choice. You have fixed it within that range. And now, you have got two summations, one over M, another over L. Okay. So, start with M equal to 0, because M equal to 0. So, start with L equal to 0, L equal to 0. If L equal to 0, M is taking all values, but all values are not allowed. Which value will be allowed? So, that this is either 0 or capital N. So, and M again varies within this range. So, L is 0. Okay. So, n minus M either 0, there is M equal to n, or it is M capital N, okay, or minus n like that. But you see, if n minus, I repeat again, L I am taking 0. If L is 0, what is the possibility of M? N minus M minus this 0, n minus M minus 0, that should be either equal to 0 which means m is minus n, or if it is capital N, then small m will be n minus capital N, but that is not allowed, because if n is within this range, if you subtract capital N, you are going outside the range to the left. Okay. But small m cannot take this value, because small n is within this range 0 to n minus 1. If you have this scale, small n can be anywhere here from 0 to n minus 1. So, from small n, if you go back by capital N, you are going behind. So, that is small m cannot take any value from that range, because small m range is from 0 to capital N minus 1. So, that is ruled out. If it is minus n, it will be n plus n. So, you are going to the right, from small n you are going to the right, you are going beyond the range, that is also not allowed. And similarly, plus 2n, minus 2n, plus, so only they are not allowed. So, only n minus m equal to 0, which means small m equal to n. So, if L is 0, small m will be n, and the product will be x 0 product will be L 0. So, x 0 into h n. Then suppose L takes 1, L is here 1. If L is 1, what should m take? N minus m minus 1. If it is 0, m will be n minus 1, that is this side. Okay. This is now n minus m minus 1. Either this should be 0, which means m is n minus 1, which is fine. Small n is here, so n minus 1, that is fine. But if it is capital N, that means small m will be n minus 1 minus capital N, n minus 1 minus capital N. You are going beyond the range of m, that is not possible. If it is minus capital N, it will be small n minus 1 plus capital N, small n minus 1 plus capital N. Okay. So, even if you are here, small n minus 1, you are 0, plus capital N will take you outside this range. So, that is not allowed. Okay. So on and so forth. So, which means when it is 1, it will be h n minus 1 dot 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 dot. When it is n, when L is n, if L is n, then n minus m minus L, and L is n. So, you have get only minus m. So, this should be either 0, means m is 0, which is within range, but if it is plus capital N or minus capital N, m will be required to be minus n or plus capital N, like that, which is outside the range, ruled out. So, m is 0 then, that is the only possibility. So, x L is 0. Okay. That is one part. And then as I go further, L suppose is n plus 1. This is very interesting. X is L. Then n minus m minus L, that will be L is n plus 1. So, it will be okay. If this can be 0, then m is minus 1, that is outside the range. So, this equal to 0 will not consider. How about this equal to n? If this equal to n, is that possible within the given range of small m? Okay, it will mean small m equal to minus 1 minus n, not possible, because m goes in the negative direction. But how about minus n? If it is minus n, then small m will be n minus 1, which is fine here. So, that is that is the only possibility. So, it will be h n minus 1, then x n plus 2. If it is n plus 2, L is n plus 2, it is minus m minus 2, that cannot be equal to 0, because then m is minus 2. So, this is ruled out. That cannot be equal to n, because that means small m equal to minus 2 minus n, I am going in the negative direction, beyond the range not possible. Minus n is okay, because then that will mean m equal to n minus 2. So, here which is in the range, so it will be h n minus 2, and this way if you go along, finally when we are here, there is L is n minus 1. So, n minus m minus capital N plus 1. Okay. This will be, if it is 0, not possible, because then m will be n minus capital N plus 1. Okay. N minus, that is, even if n is n minus capital N plus 1. Okay, that is not possible. So, this will be actually this is outside the range, but from here only you can see x n plus 1 h capital N minus 1, it is n plus 2 h n minus 2, n plus 3 h n minus 3. So, if you add these two indices, small n plus capital N, again small n plus capital N, 2 cancels. So, that means, if it is n minus 1, it will be h small n minus 1, small n plus 1. Okay. This is the summation. This part we will explain, we will consider again in the next class. This is called circular convolution. In this part is a linear convolution between x and h, but there is an additional component that comes, and together, I mean, it makes a circular convolution. So, it does not give us the desired linear convolution result because of this additional term, which is, you can say, kind of error term. Error in the sense that I want this, but I am getting a mixture, addition of the two. Okay. We will discuss this later in the next class. Thank you.